Hey folks, welcome. This is another episode of Code Gets Creative. I'm Andrew. Let's see, I'm just getting set up right now, so I'll have everything up and running really soon here. Yeah, we're doing some Screeps. Just getting this fired up. We are going to do a dedicated server, kind of like last time. This is going to let us iterate a little quicker on our code and be able to see it work, at a speed that's easy enough to make changes to quickly. Zos42, hello. Hey, welcome. Thanks for being here. Let's see. Oh, you know what? I've already done this wrong. I actually want to start the normal client, and then there's a button inside of there to start a server. So, okay, do that really quick. Here we go. We'll start a server. Now you can see we've got a client and a server up and running, so we can see stuff, and we can change details about the world if we need to. Okay. Enter the localhost server. Cool, and we're up and running. And let's see, we will minimize Steam. That's doing its thing. You can see we've got a couple of bots doing their thing as well. Yep. Got one up here, got one up here. We are down in here. Jump into this room. Cool. So, oh, and actually, let's just double check that everything's running to do hot reload on our code. I'm gonna minimize all this stuff. Yeah, we just need this terminal window. So hot reload is happening over here. And let's see, if I just go to main.ts, I should be able to make a change right here on loop. And we should see this every tick. Yeah, and sure enough, that's there. Okay. Cool. So yeah, the objective for today, switch over to here. So the objective for today is kind of the same as last time. We did a stream on Tuesday as well. This is going to be all about automating exploration and automating expansion in other rooms. So we've got our one room. Everything's broken out into roles for doing different tasks, right? One of those roles is called Explorer, and so we need that Explorer role to be able to do things. Currently, it's not able to do very much. It basically spawns in a homeroom, and then it can move up, down, left, right from there into the adjacent rooms. The rooms themselves will actually do some logic when they are discovered. They'll switch into what's called an explored role. That's cool. We can do that. I think what we need to focus on this time, though, is we need some central way for the room, like the home room and the sort of Screeps Empire data structure, to send instructions to the Explorer creeps and say, your mission right now is to go into this room or that room, or to expand to a distance of 2 from the home room, like that kind of stuff. And so that way, there's not a lot of logic in the creep role itself. It's kind of centralized away from that. We can reboot, like if a creep dies because it wanders into an enemy base and gets blown up, we can create another one. And yeah, we'll be able to keep like we'll be able to keep a really powerful algorithm kind of contained in a way that is going to be easy for us to think about and make changes to. That's what we'll be doing. Let me pull up my browser. Oh, nice. I totally forgot to set this up. Enjoy my tabs from Project Night the other day. Let's see. I want to open up Excalidraw. By the way, if you haven't seen Excalidraw, it's really great. Here we go. Switch over to that. Yeah, this is some stuff that we drew up last time. We got some data structures to work with. So suppose that this is the map of the world. Number 0 here is the home room. So we're in this home room. We want to be able to expand out from that. And so we're building a graph data structure, right, that looks like this or like this. And every time we move out from it, we're going to keep track of those rooms. So this is a room with a distance of 1 from that home room. Same with this. And then this is distance 2, right? Distance 2. This one, suppose that we're just discovering it. We'll figure out that it's a distance of 2 as we discover it. So that's what we're doing there. The thing that we need to do this time, though, is we need to actually send the command to the creep to say, hey, you should now go out to this room or this room, right? That's kind of missing right now, or rather, like, it's hard coded into the role for the creep that's like, go to this room, go to this room, go to this room, go to this room, and then like just stop. So yeah, I think that's where we're picking up basically. Oh, nice drawing website. Yeah, this is a favorite of mine. So it's called excalidraw.com. Here, I'll check this in the chat. Yeah, really fun, like sketching sort of website. So you can just like, draw little things here, change their background, change their stroke, whatever. I really like to use this at work actually with my coworkers, because it works sort of like a whiteboard. It's great to, like, before you start writing code, you can draw pictures visually with a whiteboard to make sure that everybody's on the same page about what you need to build. And then as soon as you know that, it becomes a lot easier to actually code it. So shout out to Excalidraw. Everybody give it a try. Let's see. They're all still doing their things. Cool. You can see, yeah, we've got some extensions being automatically built. So that's cool. And then here is our, yeah, we've got an explorer that has wandered into this room. In diagrams.net for a long time. Yeah, yeah, I've used diagrams.net as well. It's pretty good. In fact, it probably has more features than Excalidraw. So yeah, you might find that Excalidraw is missing some of what you're looking for. Some of the things that Excalidraw does have, which is really nice, it does actually have a collaborative mode, like, built right into it. So you can share this with coworkers or friends or whoever and work on the same session, and that's just a free feature, so that's great. Tried to save image, it was just restricted quality. Oh, that's frustrating. So you get like all the way into it and you're like, yeah, this is exactly what I intend, and then it won't like export what you see. Yeah, that'd be really frustrating. Cool. Okay, let's make kind of a to-do list of how we want to do this. This is what we did on Tuesday, right? So we need to say like room gives instructions for explorer creep. And let's see, what are those instructions basically? I mean, like, we could have a queue of rooms or a queue of instructions, basically like a queue of things to do, and then the creep picks up the one on the front. And I would love for this to be like the room just figures out when it's been accomplished, so that the explorer just like shows up, and then eventually it's going to get a new task. So I like that. That means we're going to have to come up with some data structures for what do those instructions look like that the explorer creep will see. Let's see. Tried Excalidraw just now. Good, the arrows stick to objects. Yeah, I really like that about Excalidraw. Attempt to not retry what I did. Yep, browser screenshots. you just zoom in really big, right? You're like, okay, I want this at high quality, so I'll just, really do that. Cool. Yeah, let's see. It's actually very useful to have scouting code. Yeah, totally. So we know we need the scouting code. We just have to decide where the scouting code goes. Like, is it the room that makes decisions about scouting, or is it the creep itself that makes decisions about scouting? And in the end, like, the result is the same. The rooms get scouted. There's sort of a nitpicky difference about like the maintainability of the code. Oh, I was lazy and didn't have any scouting creeps in play for so many years. I just use observers. Yeah, fair. Like eventually you get to that point, right, where you can just observe the rooms. The cool thing about doing this though is, I mean, you can have an explorer creep as soon as you want. Here's what the code looks like for my explorer. So yeah, this is all TypeScript. You can see I've introduced an interface called creep role. So in order to define a role for a creep, you have to have these three things. So you have to have the name of the role so that we can register it. You have to have the body. So like, okay, given the energy capacity of the room, how should you actually build this creep? And then how do you actually run the creep itself every tick? So that's what we're seeing here. And so the bulk of it really is run. You'll notice this is a state machine. So I wrote this function to do state machines. Yeah, and this is nice because it makes it really clear what the creep is doing at a high level, and you can kind of separate out like what the creep is trying to do from how the creep is doing it. That's the real benefit from state machines. I played Screeps quite a bit a few years ago, like 3 years ago, and I realized that all of the code for the creeps themselves was hard to maintain. It was like hard to make edits to it, hard to do more powerful things with the creeps, because it felt like it was all spaghetti code inside of the creep roles. So eventually, when I came back to Screeps just a few months ago, I studied up on state machines and learned how they work, and then I wrote this. Yeah, very true. Yeah, maybe you're feeling that as well. So check this out. This is a very, very lightweight state machine implementation. It's not perfect, but it's pretty good. It gets the job done. And it has made my code much easier to understand and much easier to change. And so I think I'm doing a lot better as a result, actually. So let's see. Let's maybe look at it like on the left first. This is how the caller uses things, right? And then this is what actually runs it. So notice how the Explorer has this idea of states. There's a waiting state and an exploring state. There's also the initial context, which basically says when you're very first creating this creep, you got to start with something, right? And so you're going to start in a waiting state. Your previous state is null, meaning like I wasn't doing anything before this. And so tracking the previous state and the current state is useful because then you can recognize state transitions. And you can say, oh, if I'm moving from a waiting state into an exploring state, then do something special. And I do that with harvesters, for example, where I say, let's say that this he's probably not a harvester, but when you go to harvest energy for the first time, pick a source and then save that into your state. You say, this is my assigned source, and then just keep going back to it forever and ever and ever. And sort of variations of that. And so those state transitions help you to do that, help you to decide when to save things into your state. Really useful stuff. So notice how there's this tick function inside of each state, right? We get the context, which is basically, we either get this or we get something that's in the form of explorer memory. And so we're going to get that, and then we decide what to do, right? So we say, oh, actually, if there's something in the room queue, then return exploring, which basically means transition into the exploring state next tick. That's what that's all about. So here's exploring. Notice how, this says if that queue is empty, transition back to waiting. So there's a way to go forward and back in these two states. And then we've got abstractions for like, are we in the room we want to go into? If not, go into it. So that's the idea there. The way that we do that is with a little bit of treating functions as first class, right? So we say, here's a creep, here's a state machine, here's the memory namespace, which basically means like, where do I go and look up, like what's the key that will actually give me this thing? And so, that's what that's doing here, right? So we say like, sorry, this is initialization. So we say, actually, if you don't have any memory at that location, go ahead and create it based on whatever the initial context should be, right? So call this function. This is your very first thing, and then move on, right? At that point, we can say, okay, this is the memory context. Let's see, is context per creep or per or a single instance or per room? Yeah, good question. It's per creep. So this is the memory context for this creep for this role. So let's see. I can show you an example of that. Actually, let's go find the explorer because it should be in here somewhere. If I switch over to here, we need to get the name of the creep, and then we'll know where in. Oh, I think the creep died. It expired. Okay, let's make another one really quick. Let's see. Game.spawns.spawn1.create explorer. Here we go. Nice. So here goes our explorer. Let's grab that. Let's see, 364. So if I open this up, 364, yeah. So here we go. So notice how it says role equals explorer, homeroom, target room. So this is all above the context. But then we've got role explorer, right? So if I open that up, notice how we have state exploring, previous state exploring, because we're several ticks into its lifespan, and then it has two things in its room queue. Now, notice how it just went to this room and then it's come back. So if I refresh this, hopefully I can do it fast enough. There we go. Notice how there's only one thing in the room queue now. It's transitioned. It's going to end up in this other room, and then it's going to run out of things to do. And so it's going to transition into a waiting state. So it's in there. It's now done all of its work. Refresh. I can probably just click refresh here, can't I? Oh no, these are just edits. Okay, so role explorer, notice how it's in a waiting state now, and it's been in a waiting state for several ticks, and there's nothing in the room queue. So so we just saw all this code execute, right? It managed this room queue, it shifted off of the room queue, and ended up in a waiting state. I sometimes use a fetcher to see creep memory by just selecting it in room view. Let's see. How do you do that? Sometimes use a texture. Do you have maybe like a command that's injected in? Or... Oh, yeah. Isn't there... There's actually like a button for that? View memory. Oh, and then it'll... Right? Will that take me there? Oh, and then it puts it here. I see. It adds like a wash for it. Nice, yeah. You want to change it? Yeah, it's this button here, isn't it? That's the one. It just adds it here. Yeah. Okay, thank you. Yeah, I should use that. Obviously, digging it out of this list is, or this map is not super fun. So perfect. Cool. Okay, so yeah, let's take this apart a little bit. I think we need to actually remove some of this so that the room can kind of centrally manage it. So I put this over here. Let's see. Here's rolled out home. So you'll notice the architecture is kind of similar here for rooms. So let's see. We have this idea of room role, right? I can open that up. And it has run. I'm not using state machines here because they don't, like, rooms don't really move between states per se. Or I guess you could model it that way, but the states last like hours or days, essentially. Basically, you might have like a home room or an explored room or an outpost room, but I felt like it didn't make a lot of sense to switch between those states because you're working through thousands and thousands of ticks within that state. So this is the architecture I went with for here, where basically a home room always does these things. It always auto spawns. It always processes events, like it recognizes when it increases the room control level, and then processes just directives. And directives are things like up here. It's like, oh, you just went up to RCL2, right? So now that you've gone up to RCL2, start building all the extensions that you can. Once you're done, build some buffers. And buffers are a special kind of container, basically. Once you finish with that, set the creep requirements. So you should have an expectation that you should always have these creeps for this room. And if not, then spawn whatever is the top priority out of that list. So anyway, we've got all that stuff working. So I think we need to have something here, basically, that's like process exploration. Let's see. Oh, so before build it will not create requirements. Yes and no. So I've also got a chunk right here for RCL1. And so when you very first spawn into the MMO world, you're already in RCL1. And so essentially these get queued up immediately. And so the very first thing that the room will do is set these creep requirements. So you should have 2 upgraders and then you should have 2 dedicated harvesters. The upgraders will go and like harvest their own energy if it's not available in storage, but they'll prioritize storage. And so eventually you get harvesters and then you get buffer containers and it becomes more optimized. But the room can totally support itself even if it's just like this, right? So that's what that means. Wait for spawn is specifically to help with the sim room. So you can simulate when actually you don't have a spawn just yet. It'll wait for that, and then it'll plan the base. And speaking of flags, you mentioned flags. You can see some flags here that are mapping where future construction sites will go. So all these gray ones are eventually going to be roads. This will eventually be a tower, and storage. So kind of get the idea there. Flags are not necessary here. You can just save it in memory. This is kind of nice because it shows visually what it's going to do later. But yeah, that's an implementation detail. So notice this though. I've got this comment in here for colonize next room ? Because potentially we could, we could define a directive here that's like type explore. And then we might have some metadata inside of there that's like max distance 1, something like that. And I think this is not going to like it because it doesn't match our directive type. So we can fix that in a minute. I'm trying to decide if this is the right way to go though. And the reason I say that is because directives get queued up, and then they're in progress, and then they're complete. And so I don't know if I want to say that, like, do this once and then you're done. Is that code only run once of our RCL change? Yes, it is. And you can see the problem with that, right? Where this means I'm only going to explore one time with this configuration. But really, I want to be constantly exploring. So I guess one alternative that we could do is maybe like set exploration rule, something like that. And what the way that this reads now is like, and I think I would actually do this like at the beginning of an RCL upgrade. But what this could mean is as soon as you go to RCL 3, time run is dangerous because it can be skipped. Yep, that is true as well. So this does have a queue. So it won't get skipped actually in my implementation. The reason for that is because, let's see, where is it? Roll home. Notice how we have directives. They can be pending or in progress. And so this array right here queues up all those directives that you see, and then it'll take one at a time off of the front of that array and put it in progress, so it's actually working on that. And so I could start building extensions, but I'm not going to follow a building plan until this is complete. So it's a durable queue. If memory will not be lost, I guess can rely on this. Yeah, that's true. I mean, if you fill up your memory, then you run that risk for sure. I've been pretty space efficient so far, so I haven't ever had problems yet with running out of memory. You'll notice that a property of this is that we're only ever going to have a maximum of 4 things on the queue at any given time, right? Because if I go up to RCL2, then I'll put all these 3 things, and then I'll finish this and remove it, and then I'll finish this and remove it, finish this and remove it, right? So I've gone from 3 to 2 to 1 to 0. Eventually, though, I'll get to 3, right? And I'll put all 4 of these on. So now I've got 4 things in the array, down to 3, 2, 1, 0. And so I'll never have 1,000 of them. Another way to say that is it's not... Another way to say this is it's bounded in its size. It's not going to become unbounded and run away from me and just fill up forever and ever and ever. I have control over that. Wonder what you will need. I wonder if you'll need parallel active directives. I think in the future I might. This is working great for me so far. I mean, where's an example of this? So here, I say, build all the extensions, and then when that's finished, go build the tower, and when that's finished, go build the roads. I could just say, as soon as, this is RCL3, as soon as this room hits RCL3, then just, build everything, I could do that. I found that has not worked very well for me because it divides the attention of the creeps based on their implementation. And so it has at least seemed to work better for me where I have them do one clear objective and then finish that and then start on the next one. That being said, if I wanted to, I could totally add the idea of like, you know, parallel true, something like that. Or I guess I could also write it as like blocking true. You could express that idea. Let's see, I use it create threads. For example, each 20 tick upgrade structures. Yeah, very nice. I remember seeing like a threads style implementation in Screeps quorum, and I'll bet a lot of the other like big open source bots are written that way too. So that's a really cool implementation. Yeah, and you could basically figure out like how many threads, can you get away with, and like scale up or scale down that way. That's cool. You could also, like, you could create the concept of, like, this is a thread for a short-lived process, like build the extensions and then stop. Or it could also be like a long-running process, you know, think like a web server, where it's like, just always run the tower. You know, sounds like that's an example of it. So yeah, that's really cool. So, okay, cool. I guess in this context, I don't want to rip all this out and replace it with threads just yet. That could be a cool project for later. But I think, like, given this, like, how do we want to express the idea of exploration? And I like the idea of maybe saying, like, when you hit RCL2, then you care about beginning to explore. No, really, I could start exploring like right from RCL1. I think that wouldn't hurt too much. No, I don't know if I want to do that. I think part of exploration is like you have to have explorer role creeps to do that. So I don't know if I want to be like spending. You don't spend very much time in RCL1 though. You really don't. So yeah, probably somewhere in RCL2 is where I could like begin to do this. So maybe we say like, as soon as you hit RCL2, then you care about exploration. So we do that. Yeah, you can go from there. So we've already got the idea of exploration here. So I think we could say like max distance, and it initializes to 0. And notice we've got exploration defined here. So I'm going to say max distance is a number. Initializes to 0. Okay, let's see. So directives can be completed. I guess some pluggable logic can implement with persistent directives. They don't block the next directive from starting. Yeah, maybe a directive that enables a flag. Yeah, totally. Or it's like a directive that changes a flag that's an integer rather than a Boolean. So like this implementation, essentially whoops, sorry, wrong keystroke. Basically this flag says like your max distance is 0, like don't bother exploring yet. But then as soon as we hit this, like go ahead and explore a little further. And so that can do its thing. Yeah, then I think there's the question of like, you know, when do we go to number 2 and 3, etc. That's all tunable, I guess. So we don't need to like get it all right exactly right now. But maybe just for now, we could say, okay, when you hit RCL3, now you care about exploring to a distance of 2. Something like that. And I think I don't know. Let's maybe just like extend this. You do spend a lot of time in RCL3. And I want to colonize sooner rather than later. So one objective that I have personally, this is like not my bot, but this is me, the person, is I want to automate this fully, right? Like I want a fully automated bot. I think that'll be a really fun challenge. But another challenge I want to add for myself is I want to expand as quickly as possible. Like I want to treat it like kind of a traditional RTS where you're using your resources as aggressively as possible, and you're rapidly expanding and scouting and making choices like that. And so as a result, I want to try to colonize the next room, whatever that may be, when I'm still in RCL3. So like you'll notice like I don't even have a storage yet. That only happens like part of the way through RCL4, right? But like by the time I hit here, I want to be able to say like I've seen all the rooms around. I know which one is the best. I've chosen it, and now I'm going to send in whatever I need to take it over. I feel like scouting range should be something that is controlled fully by scouting module class logic. Yeah, maybe. I mean, yeah, this exploration module essentially covers most of it. I guess maybe the difference that you're bringing up is like the decision about the scouting range is actually being made by something other than that module. So yeah, I think that's a good, like a good discussion to have. Like, should we put that decision in here as well? Exploration module can get RCL? Yeah, that's a good point. We could say the formula is basically like, yeah, whatever your, RCL -1 is your max distance. Yeah, let's maybe try it like that. I like that idea. So we'll get rid of that. In other words, we are always exploring. So let's see. We need to remove some of this stuff again. So I think we are going to have something like this. By the way, Zos42, you mentioned the idea of threads, and suspending threads. This is my poor man's implementation of suspending threads, and basically saying like, run this every 10 ticks. It's very, very, very ad hoc. Eventually I'm going to grow out of this for sure. And that's probably like, this will become the bottleneck that will make me move to threads, I think. Because eventually I'll have several homerooms, because I will have colonized them and taken, grown them up into homerooms. And at that point, every time the game tick mod 10 equals 7, I'm going to have this big, big CPU impact where like process recovery state happens for every single room. So when we get to that, we're going to have to rip it out and add threads, I think. If you're not limiting CPU at that point, it is completely fine. I want to keep CPU under 20, actually. Like I want to go to shard 3 and just play it that way. So yeah, I mean, I think we will run into that problem likely eventually. So what that means in the meantime, I think, is I'm just gonna keep kind of like growing onto this concept, knowing that it will become a bottleneck. I'm just gonna put on 8. These numbers are super arbitrary. Offset it. Be lower spikes on average, but it did not. Yeah, it would probably be pretty easy to be like, room tick offset equals whatever. Pick a random int, something like that. Cache that for the room. Bucket will amortize all that. Yeah, that's likely true. So let's see. We will process exploration. And we'll do that for the room. I think we'll want to call it like that. So, let's see. We've got some stuff here. I think I want the glue code for processing exploration to live here, and then this could be the bulk of actually, like the real implementation for exploration. We'll call into it here. Had plenty of game.time mod value conditions for certain logic. Yeah, totally. I think it's a totally valid like way to start out. This comes after recovery state, doesn't it? Yeah. So here, I will put it down here. Cool. So now we are processing exploration. Let's kind of pseudocode out what we want this to do. I think we want to say like get the room's RCL. Like decide whether to spawn an explorer, because maybe we actually need an explorer. And then we could probably say something like create a queue for the explorer to take over. So it's a work queue, really. Well, I guess there's another part of this, right? So it's like, if there is already an explorer, then we need to like add on to the work queue. I think it's gonna look something like that. My pseudocode indentation was not correct for a minute. Yeah. Okay, cool. So let's see, I remember. Oh, I got rid of that. That's not needed. So what I'm gonna do, I need to be able to grab I need this, basically. And actually, I'm starting to do this quite a bit. So let's say get roll home memory. Yeah, so I'm doing a type coercion right here. I don't know if y'all are familiar with TypeScript or not, but basically, I don't know which type of room I have at this point in the code, or at least the compiler doesn't know. And so what this says is, hey, I'm putting this in this module where I know I'm only going to call room with this role, because it's in here, right? It's in this module, and so I know it's safe to do this. So I'm going to go ahead and do this type coercion. Let's see. This is going to return whole room home memory. And let's see. I'll put that here and here. And up here, I'm not going to do it because this is where I initialize things. Let's see, and then I'm also going to do it here. Let's see. Could be multiple explorer creeps. I would make a code pretending there's an explorer. Yeah, I think that's fair. Maybe we write it that way first, and then if we need to, we can, or we'll grow into that like second case where we need to spawn one. Let's see. So at this point, by the way, this is one of the big reasons why I use TypeScript, is because it's auto completing things for me, right? And it keeps me safe, right? Because if I type something wrong, it's just not going to compile. But it's also like informing me along the way. Kind of cool. Or it can be when Explorer finished to move to some room, it requests the next room, and it will be decided at that point. Make it with 0 explorers, that code will not be triggered. Yeah, I like that implementation. That works really well with the state machine, because then we can say, as soon as a Explorer moves into a waiting state, that's when it calls into the exploration module. So yeah, that's cool. Let's maybe do that. So I think we need to say get the next room from the exploration module. And then go there. Yeah, and then I guess yeah, calculate what is next. So yeah, let's see. What this means is that we need to be able to call okay, I'm going to move some things around. We need to be able to call into the exploration module. I think essentially I want to say get next room to explore. And I'm going to pass in the creep, and I'm going to pass in the home room. Auto-completing is very handy. Also static type checks on compiling. Yes. I would much rather have a compile time error than a runtime error. Cool. So this should give me next room. And I think I want this to just be a string, I think. Let's say next room is a string or null. We're going to delete the room queue. We're going to say next room initializes to null. This get adjacent rooms, I think we're just going to throw this away. But we will find out in a minute. So next room, and then I think we'll say if there's a next room, then we'll say context.nextRoom equals next room. And then we will transition into the exploring state, because at that point we'll be like, cool, we know what we need to do, let's go do it. Otherwise, return null, stay in the waiting state. Let's see, we do need to get the home room. And that needs to be of type room, I think. So let's see, we do have creep.memory.homeroom. This is so that's a string. This is just the name of the homeroom. So we should be able to say game.rooms at this index. That's a type room. Pass that into here. We will either get a next room or we won't. Okay, let's also look at exploring. So I think we can say if not next room, context.next room, then go back to the waiting state. Let's see. Then this should be, yeah, we have a target room. It's no longer a queue. And say, just got to the target room. And then we don't have a queue to pull off of. But once we get into this, we're ready to transition back out. So now I want to say context.nextRoom equals null, and then return waiting. So we explore, we finished exploring that room, now we're waiting, and so that's going to give us the next room. Like we'll come back up here. Cool. This is an early return. I think it'll be more clear to just do this now. Okay. I don't think we need this log. That looks good. Let's actually implement this now. So let's see, we will give it a creep and a room. And this is going to return a string or null. Nope, return null. Implement. Yeah, cool. So you got that. Let's see. So pulling that out now. I don't think we're going to shuffle here anymore. I'll remove that. So get adjacent rooms, I think might be... Yeah, we might end up calling this in here. So let's pseudocode this out now. So we need to, let's see, get the room, decide max distance based on the room RCL. It is like recording room info. Yes, so the room info, yeah, is stuff that you see up here. Yeah, you'll probably notice some stuff that's actually in the Screeps API itself. So room position is essentially the same as the Screeps API room position class. We just need to be able to serialize it, right? So we'll save this into memory, and we'll save that for the sources, for the controller, that kind of stuff. But then we also want to know this stuff, and we'll save it into our list of rooms. And we're choosing to do this in memory because we need to be able to look at this data structure even if we're not currently in the room. So if I'm not in some room, then I can't actually query into the room. It's not available. And so yeah, we're going to end up caching this stuff. Can access describe exits without room vision? Yes, that's the reason why we can use that. It's going to be a matter of saying like, okay, what are the rooms that I do know about? Describe the exits from each of those. Look at whatever I don't have yet, and then pick one of those. Let's see. This is always homeroom. So the reason I'm going to call it homeroom is because I actually have to do another type coercion here. I have to do the same thing that I'm doing over here, There we go. So I think there are probably ways that we could say like room of type role home, something like that. I haven't built that out yet, but when I do, I can get rid of a lot of these coercions, which will really clean it up. It'll make it a lot safer. Whenever we do one of these, it introduces this risk that we might have actually done it in the wrong place, or there's some edge case in which case, like, this is not actually true. And if that happens, then everything below it, we don't know how it's actually going to run, and we could get runtime errors based on types. Let's see, that's exported. You just got to import it. Now that's available. RCL equals role home memory dot RCL. And I think we've decided, like, our formula is basically just like RCL plus 1, isn't it? That's kind of how, like, we were typing it out here. So yeah, let's do that. Max distance equals RCL plus 1. If homeroom will be lost, it will be room is not an object. Yeah. Yeah, that is worst case scenario. Like if somebody destroys my homeroom and everything's gone, then yeah, I'll get a lot of exceptions. I'm willing to write it like that for now. When I get more into combat, then I think it's going to force me to fix a lot of those edge cases, because I'll be like actively, you know, I'll be the aggressor that will cause other people to come in and like cause those sorts of edge cases. Yeah. So we've got that. So we need to be able to say like, get all the rooms that are within this max distance. And then we want to be able to say visit a room. Let's see. If any rooms have not been explored, explore that room. Explore those rooms, right? Else, pick the next. We want to say like pick the room that was explored like the most ticks ago. Explored for the longest time. Cool. What I want to do at this point, I want to open this up and look at roll home, exploration, rooms, and I can see my rooms right here. This one gets created at the very beginning, and then we get these that are distance 1. Later implement creep assigned a new home. Making closest own room. Yeah, I like that. Oh, sorry. With creep entities I use in my code, I always ensure creep's homeroom exists in its constructor. I think it's just sacrifice. Yeah, cool. So you've protected against that edge case. And like you lose the homeroom, you go find another one. I like that. Yeah, I should go in and add that later when I get more into combat for sure. Okay, so we've got each of these. Get all the rooms that are within this max distance. See, I almost need like this is going to turn out to be maybe sort of computationally expensive. So maybe there's a smarter way to like memoize it in memory. I don't know. So you measure distance. I also have similar logic. I did some room info recording code before. Yeah, you kind of get the idea. Yeah, I'm worried about this line right here because there's some things that we know and a bunch of things that we don't know, right? So let's break down this algorithm a little bit more. Take all rooms, or maybe it's like take exploration.rooms. So we have that. And then we need to... No, I think it's going to be like create a set of rooms. And then we're going to say add every room in exploration.rooms to the set. So whatever's in here, we're going to add that. Like, we know about all this stuff. Then we're going to say add rooms that are within max distance that have not been explored yet. So, for example, if we only know about the current homeroom, then our max distance is 1, but we haven't, like, we don't have a record of those rooms that we want to explore. And so this is the point where we're going to say, oh, actually, our homeroom has these 2 exits. Take this, take the room names there and add them into that same set. Yeah, some thoughts about room distance. It's all in relation to the current room. Yeah, that is true. And you end up kind of rebuilding it. Yep, if you only have one room, maybe it's not a problem for now. Yeah, honestly, that's kind of how I see it. Like, we'll have to worry about it later for sure. But I think, yeah, we'll get to the point where we'll be interested in refactoring this, so it's a global one. And honestly, I don't think it'll be a very difficult refactor. We have to have the logic for having a map, and then eventually it can be a global map. Cool. So I think this logic should work. We do need to know, like, it's probably like a set of rooms and whether they have been explored. I don't know. There's like, maybe we just create a bunch of room metas. I think that could work. Of room meta objects. But let's do that, and I think that'll pay off. And a bunch of this will just be set to null. Although this does mean that we need to say like explored Boolean. Or actually, we could model it like this. I like this better already. We could say type unexplored. So we just pay attention to the type. I thought create a map of rooms if it is not already created. Yeah, so we do have map, and that actually gets created here. So we say when the homeroom initializes, create a room meta object for it, and then push it into rooms. So this will have that one thing in it. It's not going to have the other ones though. And so that's the problem that we're running into, is it's an incomplete map. So I'm gonna lean on this new type of unexplored, and I think that's gonna help. And eventually we need to say like last explored number, right? Because that's going to help us with this part of the algorithm. Okay, I use this method and saved explored data directly into memory.rooms. Yeah, that would work as well, like that. Okay, cool. So I think this is a function. So let's say so I'm going to give it the homeroom, and I'm going to give it the max distance. And this will be like nearby rooms. So the homeroom is a room, and then the max distance is a number. And this is going to return a set of room meta. Let's see. Let's actually just call this nearby rooms, huh? Get nearby rooms. Pass that in. We're gonna have to do the same type coercion. Ugh. Or I guess one thing that we could do is we could just pass in the exploration object. We probably don't need a variable for that. Okay, so this is an exploration. Exportation, I think is what I just typed. We have that. Got that. And let's see. Yeah, so we don't need this coercion anymore. That's good. Let's see. In current situation, I would not waste my memory.rooms for that. I would do something more like memory.explored rooms. Yeah, totally. Like if you've got kind of dedicated memory for your exploration, then you know that you're putting it to the use that you think you are, kind of a thing. You're cleaning it up when you intend to. You're allocating it when you intend to. I like that. Okay. All right, so we have our new set. Eventually, we're going to return it. That comes in here. So now we could say something like, and I'm going to go ahead and implement the top level algorithm first. So I'm going to say nearby rooms dot, and oh, is dot find not a? I thought it was. Okay, cool. Nearby room. in, I mean say object dot, okay, let's go to MDN, yeah? let's do this right the first time. So this is a set data structure. For anybody that's new to a set data structure, a set is kind of like an array, right? It's a collection of data. It's unordered. So, you know, imagine an array where like it's not actually like thing 1, thing 2, thing 3. It's just kind of a big jumble of them. But it's really fast to look them up, and you can't have duplicates. So this is a good thing that we can use here. How will set be more beneficial rather than array? Yeah, so in this case, we know that so it'll deduplicate it for us, which is nice. The return value should be some kind of collection. I guess we're still going to iterate through it, you know, in some order. You have room info type. Yeah, I guess you're right. Like maybe there's not actually a value to it. It's like semantically, I feel like it makes more sense than an array. Like that's one definite benefit, is like the code is maybe clear in what it means to do. And that is a good reason to write code in certain ways, you know. Like even if there's no performance benefit, but it's clearer, you know, so that your coworkers can understand it or future you can understand it, then maybe do it, right? Yeah, so I think I want to keep it as a set for now. Let's get into it and decide whether we hate it or not. Let's see, so I should be able to iterate through values. Yeah, that's what I care about. So I can say nearby rooms dot values. So then we could say if nearby room dot, and this should be of type, wait a minute. No, this should be room meta. What's going on? Oh, this should be of. Yeah, okay. Sweet, this just caught a bug. So maybe you all have run into this as well. But there's for in and there's for of. And for of is a newer, like ES 2015 plus feature in JavaScript. And so this means iterate through an array, or an iterator rather, whereas this means the keys of a object. And so I want of in this case. And so when I hovered over this, it said string, and I was like, how is this a string, right? But yeah, totally. Yes, this is how TS helps you. Amen. Love this. Okay, so now what I can do is I can say ownership. If ownership is equal to, oh no, I want to say ownership.type equals unexplored. So yeah, if any rooms have not been explored, explore those rooms. So I'm going to say return nearby room dot name, like cool. This room has never been explored before. Cool. Else, pick the room that has not been explored for the longest time. Let's see. So I think I can do this. I can do this in a single loop, which I would like to do because this will get big. I want to say like oldest room. Oldest room equals null. And then we can say something like else Oh, I need to pick. See, now you'll provide other types of rooms from get near rooms function. Makes sense. Yeah, yeah. So, yeah, this might return a room that I've already explored, or it might return like a brand new unexplored room that I need to go find. So, and this type, what is that called? The type variant, or this type within the union type lets me express that. So, problem though, I want this to just be a room meta, right? And so I can't initialize it to null. I mean, I could. Gross. I mean, we could do room meta or null. Am I okay with that? Yeah, yeah. I mean, that's not too bad. Let's do that. So I might say something like, else if not oldest room, so we haven't found an oldest room yet, or nearby room dot, and now we need to have this to, we need this to exist. If this last explored is less than the oldest room dot last explored, what's wrong with this? Does not exist on type ever? Let's see. If oldest room is null, or the nearby room is explored. How is oldest room a never type at this point? Because if we get over this or, we know that this does not exist. I wonder if this is actually the type checker not catching it. Let's find out. No, it really thinks that that doesn't exist. Let's see. Oh, we got questions about, yeah, what does the type available mean? Yeah, so here's room ownership, right? So the idea here is unexplored is like, I have no idea what the room ownership is. I've just never been there. I've never looked at it. Unavailable is like it's a hallway room. There's no controller in it. Available is there is a controller in the room, but nobody has reserved it. Nobody has claimed it. Reserved is like a specific player has reserved this controller. And then owned is a specific roller actually has claimed the controller. There's some RCL associated with it. So that's the idea there. What that means is that owned, like a room could be owned by me, it could be owned by any other player. That player may be hostile or an ally or neutral. That could be a totally separate mechanic, right? And so I've isolated that apart. Like, you know, I'm not trying to say something like hostile is a Boolean. That's for some other module to worry about. But that way, this is really nice because, and I invoke Haskell's mantra here, which is make, what is it? Make impossible types, or make impossible states unrepresentable. Unrepresentable. This is kind of cool. Yeah, so this this idea of union types is like my favorite thing. Yeah, TypeScript does this really well with this syntax. Haskell does it. If you're a fan of the Rust programming language, I'm a big like Rust fanatic. Not to be confused with the game. Rust also has an enum type that lets you do like union types like this. So really cool, really powerful. Okay. So I'm still puzzled because, like, why? Yeah, like if we've made it to this block, then we know that oldest room is not null. I guess we could flip it around. We could say, like, if oldest room is not equal to null, you know, and just write it like this. It still thinks oldest room is never. What is... Oh. Some people even program in Rust for Screeps. It's compiled in WASM modules. Yeah, that's super cool. I might have to try that one of these days. A couple of years ago, you know, I was playing it like 3 years ago and had not really, I don't know, I wasn't super deep into Screeps. And so it was like, oh, cool, someday maybe I'll try this in Rust. I was glad I tried it in TypeScript first. Because I was like not great at Rust back then either. Now I think I'm pretty comfortable with both, and so I'd be able to do a better job of it. Okay, somebody tell me what's wrong with my code. Post in chat, what's wrong? How is it a never type? Well, this room could be either of these. If not oldest room, what if I make it like really... My plans to test... I don't know how to pronounce that language. Hax or Haxa? I did not know how to set it up, though, in Slack when player pinned a message. Yeah, maybe someday. Get really fancy. That way, that'd be cool. I don't know very much about that language, so I'll have to go look it up. I've like heard the name. I've seen it on Hacker News, I think. Haxi, maybe? Cool. If nearby room dot last explored is less than oldest room dot last explored, now let me do this. Oldest room equals nearby room. So it likes this. I've created some like ugly nested branches, but TypeScript doesn't have a problem with this. Haven't tried it yet. It looks like JavaScript mixed with C#. Okay, cool. Strongly typed. What is the runtime like? Like, does it have a virtual machine like the JVM or the Beam, or is it, or does it compile like all the way to a binary like C, C++, Rust, Go? Or is it interpreted? I guess like JavaScript is. Compiles to many languages, can be compiled to JS or C# or any other. Oh, cool. So yeah, that sounds yeah, it sounds, I don't know, I'm thinking of LLVM. I wonder if it's built on LLVM. Like Rust is actually, so it's very easy to swap out the backend for us. Dolor Akshay, hey, welcome. Good to have you with us. Yeah, so what stage of the game? So right now, like we're actually just running a simulation on a private server. Actually, something has gone wrong. I think I've let my code get into a bad state, so things have stopped. But in the MMO world, I'm on RCL 4 at this point. Things are like kind of automated, and actually many things are automated at this point. Let me give myself some credit. Here, I think this is kind of a good example of like what I have done so far. So I'm leaning heavily into the idea that creeps have roles and rooms have roles. So they're different creep roles. They're harvesters and upgraders and haulers and stuff like that. I've called haulers managers. I should rename them. Everybody else calls them haulers. And I have a lot of automation around running a single room. So you'll notice we've got this idea of like RCL events mapping to directives. So in other words, when I start the game, I spawn in, I'm now at RCL 1, then I'm going to queue up these 3 directives that my room needs to process. So my room will set creep requirements, then once that's finished, it'll wait for the spawn, which is actually a simulation room thing, and then it'll plan the base. So it'll like, it won't put construction sites, but it'll basically like partition off kind of a city block where nothing else is allowed to be built there. When we get to RCL 2, this stuff gets queued up, so it's like build whatever extensions you can, build containers close to sources, get more fancy about creep requirements now that we can rely on buffers, etc. So that's pretty cool. What we're doing right now then is we're automating exploration into other rooms. And so we currently have this idea of there's an explorer role, and there's this module called exploration. And so the explorer is going to call this function get next room to explore, and then it's going to go into it. And so we're implementing this idea of like, well, what rooms do we know about? What rooms are nearby within a max distance? And then based on that, we're going to pick one of those and send that back to the creep so the creep can travel there. So that's kind of where we're at. Yeah, I use custom role names, but translate them as haulers when I talk in Discord. Yeah, for real. Drones, drone static, carrier. Yeah. So like all 3 of those are a little bit different in terms of their priorities and probably like where they go to. Makes a lot of sense. Yeah, I have 2 currently. Like I have manager, which is sort of a distance hauler, and then I have armorer, which is like I've heard the term queen kicked around. You know, like the queen that runs the hive, that'll move like from storage into extensions, but it won't travel all the way to like a buffer container that's on the other side of the room. Cool. Yeah, I call my queens managers. Oh, cool. Yeah. Yeah, I think that makes sense. Yeah, so I guess we've got all sorts of naming collisions. But yeah, that's the idea. Only carrier is hauler from this list. Okay, so yeah, ZOS42, your drones and drone static, those are probably like close range, like take from storage, fill up the extensions. Does that sound right? Let's see. We've done this. If any rooms have not been explored, explore those rooms. So go to this one. I don't think I need comments here, but then pick the room that has not been explored for the longest time. So then I'm going to say return oldest room. Oh, yes. So now we need to say if we have an oldest room, then return oldest room dot name, else return null. There we go, because we're converting types here. Sweet. Okay, yeah, so I think this top level algorithm is finished now. Let's see. Stack is static harvester, drone is generic worker, all doer. Yeah, I like that. I've felt the pain of not having like a generic worker, especially in like kind of RCL1, RCL2, like before buffers are set up. So yeah, I should build one of those. That would actually be a really cool stream topic. So maybe one of these days. You should really try GitHub Copilot with Screeps. It literally does most of the repetitive code for you. Oh, I love that. Yeah, I've heard about Copilot and I thought it was really interesting, but I didn't try it. So yeah, one of these days I need to fire it up. Because I think like it sounds kind of early days, but like it really has the potential to like change our industry for sure. And so I think we need to get used to the idea of it, and we need to get used to like working with it rather than against it or like ignoring it. So yeah, good shout out. Oh, oh, that's right. It's a closed beta, isn't it? Okay, so no, I don't get to, I guess. That waitlist is probably like a mile long. Yeah. Yeah, so Zos, it's actually it's basically like AI that writes code for you. So you can write the function name, and I think you give it some parameters, and then you invoke GitHub Copilot, like through a VS Code extension or whatever, and then like poof, it just like fills in the implementation for you, which is amazing. Yeah, pretty cool stuff. I've also seen people do kind of similar things with GPT-3. So that's usually people are using that for natural language processing, where you can like generate an article, like a journalistic article, about some topic. But yeah, people are starting to build GPT-3 like implementations that will like generate code. I've seen it with like React components that's like, make me a button component that is blue or something like that. And it'll just like produce all of the code to have a working button. And it's just the greatest. I think it doesn't like, I don't think it's going to take away all of our jobs. It's going to replace the concept of snippets. Because it's really like intelligent snippets is how I would describe it. And so like all the glue code, that I don't think there's any way that Copilot will be able to guess what the glue needs to behave like. So that's always going to be up to us, I think. But like kind of those little pieces, Copilot and GPT-3 and stuff, like those are probably going to be more and more and more like the future of how we work. Cool. While I'm thinking about it, I'm really curious. Like, we got a few people on the stream. What's everybody's backgrounds? Like, do you write code for work or do you write code for fun? That's really helpful for me to know because you can see on the channel name, right? This is Code Gets Creative. I'm gonna stream Screeps every once in a while, but you'll also see me stream a lot of other stuff. For example, like I mentioned this, last time, but like this is a little microcontroller that does audio. And so I'm going to actually build synthesizers out of this thing. You can see I've got my modular synth up here. I've got another module that I built into here. And so, yeah, like I'm very curious, like if people are interested in, interested in electronics, interested in like synthesis, and interested in other like specifically creative coding type things. So we're talking like create art with code, create music with code, that kind of stuff. yeah, this channel does a little bit of all of that. So yeah, would love to know like if y'all are doing similar things or other things that kind of fall into that category. Yeah, would love to get your input on that stuff, and would love to see you again. Actually, since I'm thinking about it, I got to show you this. This is another project. I just like hacked this together in a couple evenings. This is my like $12 Stream Deck. So if you've ever heard of Stream Deck, it's this fancy like $200 thing that'll like let you control OBS and like control your Twitch stream. I've just wired this up with what's called a Teensy LC. That's this little green chip right here. It's kind of like a Arduino, if you're familiar with that. Very cheap. And then some little like buttons on the side, prototyping wire. And so I can actually, you can see how I can like switch between scenes on OBS with this. So kind of cool. We can talk about that one day if anybody's interested. That's like it's super useful for work actually. Like I'm gonna use that. I've got another one up here. This is like fun arcade buttons. This is 3D printed. So this actually controls Zoom. So I don't know if y'all like work from home. I started working from home when the pandemic began, and so I've done my best to like kind of optimize my working from home setup, right? Because like I'm in meetings at home, and like I want a nice mic, I want a nice camera, so I figured that stuff out. But I'm also constantly thinking about like, am I muted or am I unmuted? You know, that kind of stuff. And so I basically wired this up to be a virtual keyboard. So when I press this button, it does like Command Alt Shift A or some like stupid thing like that. That basically means like toggle the mute button in Zoom, so I can like toggle when I'm speaking. And then this one is like play and pause the media. So like I can pause Spotify or pause whatever I'm listening to, pause YouTube. Yeah, so this is fun. If you folks are interested in like, maker stuff making, yeah, I'm super duper into that. Yeah, give me a follow on Twitch or a subscribe on YouTube, and you'll see more of that because I'm like all about that. Cool. So yeah, let's see. We got some really cool feedback here. Thanks everybody. So yeah, vote for both. Vote for I don't know, probably both. Cool. Yeah, that's awesome. Yeah, thanks everybody for like sharing your background and your stories. I'm all about that. Yeah, Zos, that's a fun combination of like languages and projects you've worked on. That's awesome. Very, very cool. Nice. Yeah, super appreciate everybody joining. That's just way cool. All right. Well, yeah, so in order to have this all up and running, we got to implement this, and we've broken this type now because last explore doesn't exist on here yet. That's actually easy to do, isn't it? We just say last explored game.time. Cool. Okay, so we fixed that. Now we just got to finish this. So let's see. Get all the rooms that are within this max distance. So I think we could say like explored nearby rooms, and this is basically like exploration.rooms, but then we're going to filter. I'm going to call this room meta. Room meta.distance from home is less than or equal to the max distance. And then we need to say like unexplored nearby rooms. Let's see. Are we... Yeah. Yeah, let's see. How do we want to do this? We could do something like rooms to expand. This should be less than or equal to max distance minus 1. So I guess it's just less than max distance. Oh, whoops. Yeah, so the base case is covered by that. Oh, Zaz says, I'm developing a PHP framework for almost 8 years now. I plan to use it for website projects we did with my friend, who's also my coworker. Oh, wow. So is your framework, like, are you using your framework in production, or is it still kind of like in development? Because I would definitely recommend, like, at some point you're going to want to ship it, right? Or at some point you're going to want to either like use it in your thing or else probably move on. But I don't know. Yeah, when I got enough stuff implemented, I made a project fully using that framework. Yeah, nice. Took me a year. Wow, that's cool. So what I'm gonna do, I have explored nearby rooms. Actually, let's make this concrete. So let's say that so far we know about this room, we know about this room, we know about this room. So all 3 of these are explored nearby rooms. Oh, alarm just went off. So these are explored. We want to add both of these. We want to add all of these into our list. Crazy planning. I don't know whether you're referring to this or to Zos's story about his framework, their framework, but that's fun. Super cool. I think we want to say for each of these explored nearby rooms, we're going to say nearby rooms dot add room meta. Yes. Oh, referring to your Excalibur planning. So neat and methodical. Appreciate it. Yeah, I've realized that, like, if I draw things on a whiteboard first, it super duper helps me in writing the code for it. Like, you know, I've got this like question mark here, right, to decide like what is this, but yeah, that it helps. I don't know. Like this stuff is more just like explaining data structures. So we've got kind of a range of like people's experience, right? So talking about graph, what is a graph data structure? What is a tree data structure? That kind of stuff. Yeah, both super helpful for Screeps, among other things. So let's see, we're gonna add each of these explored nearby rooms, but now we need to be able to say rooms to expand. And so then for each of these, and I'm gonna start to kind of mix and match things a little bit. Expand of rooms to expand. So in this room to expand, so for example, let's say that we want to go find distance of 2. So distance of 2. So in other words, like everything in here already exists in my data structure, right? But this one doesn't. And so we need to go find this and we need to add that in. So in order to do that, we need to say something like get adjacent rooms. Yes. Haha, Zos. This is the part that I need to grab this. So I'll put this here. Oh shoot, that was... Hold on. What did I just cut and paste? I want get adjacent rooms. I was like so hasty to grab that. I was like, it's that one thing at the bottom of the file. It's at the bottom of this file. Turns out that matters. Okay, so get adjacent rooms. By the way, for anybody that's joining, yeah, here's the Explorer role. We've gone and ripped out a bunch of what was there before and put in some new stuff. You get adjacent rooms. And now, and yeah, we don't, let's see. Just come back over to here. So for each of the rooms to expand, we need to say adjacent rooms is going to be get adjacent rooms. Right, so I do want shuffle. Okay, let's add that really quick. Here we go. So what this function does, notice how we're calling game.map.describeExits. We should go look that up in the Screeps API. The important thing, we talked about this a little bit earlier, is that game map describe exits, it's going to give you like all of these, and it'll give it to you even if you don't have visibility into the room. And that's critical because we might be expanding this data structure. From rooms that we're not currently inside of, so we don't have visibility in them. Very cool details about game development, Sauce. Very cool. Yeah, Blender and Blitz Basic 3D, super cool. Awesome. Yeah, very cool. Let's see. Getting our adjacent rooms. Now we need to like prune out any of the adjacent rooms that we already have. So let's see. And here's the thing. Our set data structure is supposed to help us at this point, but it's not, because it's a set of the wrong data type. So you know what I'm going to do? I'm going to change this. So it's a map of string to room meta. So let's see. Now I can say .set, and it's going to be room meta.name room meta, right? But now what we can do is we can say filter these adjacent rooms, adjacent room, where we have not already discovered it. So let's see, we'll say nearby rooms dot has adjacent room, and this should be a not, right? So basically, if we already know about this room, then remove it, right? So filter so that we keep only the adjacent rooms that we don't already know about. And then what we'll do here is we'll say for, and then when, I know I'm sort of mixing my style here between imperative and functional. you know, I've got for loops, but I've also got filter and map. So I think we need to go back in and like clean that up a little bit. But right here, we're basically saying like filter it and then map it. So adjacent, this is really a name. But now at this point, we can say, where is it? Create room meta? Yeah, problem is it's like create unexplored room meta or something. And then I'm going to pass in the name. So then this is just a room name. But this will return a room meta. Whoops. Return a room meta. Here we go. And then last explored, we haven't actually gone in yet, right? So let's set that to 0. Let's see. Question up here. Are you planning which rooms you're going to look at before seeing them? Yes. Yes, that's right. Yeah, the issue is that like at some there's this case in which we've only seen part of the map, but we have to know to go to the next part of the map. And so that's what this particular part of the function is for. Or this part of the algorithm is for. Oh, do I already know the distance from home? I think I do. So distance from home should, this is going to be room to expand dot distance from home plus 1. So in other words, like, we know that where are we? We're growing off of this room. We already know this exists, but we know that this is what we're looking for, and so it's this distance plus 1. That sounds good. Just write it like that. Sources are empty. Controller is null. Ownership, and this one's really critical. It is unexplored. So that way we've got that represented. Yeah, we got that represented, and we can return that. And that lets us grow from there. Let's see. I just analyze whatever rooms are made visible by my scouts. Yeah. Yeah, so you can do that. The problem is you need to look for rooms that are not that way. Like we're not looking for previously scouted rooms. We've got to like expand our scouting, and we need to do it in a way that is it is bounded. So and actually $Akshay, yeah, it looks like you're doing a BFS from your main room. That's basically a breadth first search. Yes, essentially. We're doing breadth first search, and even like it's going to shake out to basically be like a level search. So yeah, but essentially what we're doing is like, I don't want to go off like into infinity in a single direction. Because if I do this, you know, and just like pick a direction and go, that's not going to be very useful scouting. So instead, I'm kind of like, you know, I'm like forming circles. here's a very rough like concept of the thing, right? But yeah, breadth first search lets us do that essentially. I can drop a link of my old 2D pixel art version of that RTS. Yeah, I mean, yeah, feel free. Like if if you want to share anything with everybody, like go for it. Drop a link in the channel if there's something on like itch.io or Steam or something. Let's see. My scouts decide which room to go next every time they reach a new room, and they prefer rooms that haven't been visited. Okay, so yeah, so Eduter, sorry, not sure how to pronounce, but Let's see, they prefer rooms that haven't been visited. They also prefer rooms closer to home. Okay, cool. Yeah, I was gonna say if you just do that first one, then you end up with a depth first search, essentially. Like you're prioritizing moving further away as fast as possible, but when you add that extra constraint, it kind of flips it. So that's cool. All right. So let's see. I think we're getting really close to this. I've changed my type up here. So now we need to say get nearby rooms. What are we actually? Okay, so I am now willing to rewrite this as an array. Zas, you mentioned this earlier that like probably don't need an array, or we probably don't need a setup here. Yeah, like from this perspective, we don't. Like nothing in here gets any benefit out of the set or out of the big O1 lookup time. But there is something in here that does rely on that, right? And it is this. So this right here should be pretty optimized. And so having this as a map lets us do that. So now all we have to do is return. Actually, let's double check MDN. I don't want to get this wrong. MDN map. Not to be confused with array.prototype.map. Last time on the stream, I like had this whole monologue about like array.prototype.map and how like if you're not familiar with it, you should go learn it. And like the whole time I had this pulled up, and then was like, oh shoot, wrong page. But here we are. Objects are greater than maps. Nah, I disagree. But yeah, we can fight over that. Let's see. Objects can be serialized cleaner than maps. That is a big advantage. Let's see. Isn't there a dot values? Yeah, dot values. And it's a new iterator. Okay, so we just have to say array.from nearby rooms dot values. There we go. So hold on a second. We've got like adjacent rooms. And now that we've got them, we need to do something with them. So we need to say adjacent rooms dot for each adjacent room nearby rooms dot set, right? Adjacent room dot adjacent room dot name adjacent room. Cool. And so this unexplored nearby rooms, like we're actually doing this in our loop. Yeah. Cool. Nice. Okay. I think we have now done everything in this algorithm that we set out to do. If you use objects as hash maps, yep, sure, then maps can be more performant. Oh, cool. It probably depends quite a bit on your runtime, though. Like that's kind of banking on your JIT implementation and stuff. But it's probably more predictable performance, which matters. The other thing that I like about maps over objects is that like this is quite semantic. Like it's easy to see my intent based on reading this. So I can come back later and be like, aha, I'm using maps. I'm doing something where I care about fast lookups. And that's like baked right into the way that the code reads. Okay. Let's do this, yeah? I think we're ready to test this thing, and then maybe we can call it for the day, because I've actually got to go somewhere in a few minutes. We'll delete this. Run back over to here. I remember stuff died for a bit, so let's see if... Oh, man. Look at that. Things are just dead. My suspicion is that we added a bunch of... where is it? Like, we added some of this stuff last explored. So, I think we're going to have to manually tinker with our memory a little bit. And then we'll be okay. Roll home. Exploration. Rooms. And let's see, can I add... yeah. Oh, no, I don't want to do it in there. Remove. Insert? Yeah, there we go. Okay, so this should be last explored, and this is 0. So at tick 0, which is not actually true. And then let's make the same modification here. We'll say insert last explored 0. And then in here, insert last explored 0. And then we got to commit that, right? Save. Okay. Now, I think something else is wrong, though. Let's see. What is going on? One thing that we can do is like start of loop, end of loop. And I would love to know, like, are we getting to the end? Wait, we're not even... Oh, you know what? I have seen this happen before. Something is weird about my networking, and so the client gets disconnected from the server. So I actually have to, like, quit out of this, come back to... Where is it? Where's Steam? Come back over to here, stop the server. Is this my server? Yeah. Yeah, I don't know what's going on here, but like this happened on the last stream too, so I'm gonna have to solve this if I want to keep doing like longer form streams. Are we oh, there we go. You get back into this. There we go. Allow some stuff. Spin up a private server. There we go. Rejoin it. Maybe it's the runner. Maybe check the runner's console. That's this, right? Like the server console. At any rate, we're I think we're gonna be up and running now, once again. Yeah, look at that. We're back. And we're getting to the end of the loop. So it wasn't even my code that was the problem. Now we might still, like, my guess is that when we made those manual edits to the state, they probably didn't actually persist. So we'll have to go in and change that really quick. And by really quick, I mean painfully manually. Oh no, look at that. That's there. Okay, well that's great. Yeah, but you already restarted it. Yeah. Yeah, cool. I'll do that next time. Thank you for the tip. Hopefully it's something that I can fix that way. Okay, so we've got this. In order to test this, I think we're gonna have to just hard code this for a second. So max distance, I'm gonna say max distance is 2. So far we've only discovered things that are max distance of 1. So let's add just a little bit of debugging. Get next room to explore. So we'll save that. As soon as we create an explorer role creep, we're going to invoke this function, and it should give us something interesting. So let's add something in here for that as well. We'll say like got next room to explore. Oops. Put that in there. Next room is of type string, isn't it? Yeah. I started to use Screeps launcher for private server. It's more stable for information. Hey, that is good knowledge. I wonder if that would help. I'll check it out. Okay, cool. So that's all up there. I think we've got the exploration module, and we've got the explorer creep that is going to call into it. So hopefully all this should work together now. So I'm going to say game spawns spawn1 create explorer. There we go. By the way, this create function is one that I created myself and put onto the spawn prototype. So this is nice because it makes sure that it runs through the same code path as everything else. So I recommend doing something similar. What? Let's see. Time for testing. Oh, typo on spawn1. There's not an S in it. Hey, look at that. Got next room to explore. West 6, North 3. So where are we here? West 8, North 3. So we're going 2 to the west of here. You'll notice that the Explorer does this weird like pathing and then repathing. So I need to fix that for sure. It's wasting a lot of time just like wandering in this zigzag pattern. But look at this, like it's doing the thing. Oh, I love this. Let's see, and when this happens, yeah, eventually it's going to get into there. Let's see, I want to... Yeah, I want to pin that. Well, that's fine. Here we go. Going into this room. And I want to see the state transition, right? What is this? Just got to the target room. I think oh yeah, look at this. I forgot to use a template literal here. Okay, well, I fixed that. Where's it going now? West 7, North 4. So it'll backtrack and then go north. Oh, and look at that. It already got there. I literally can like not keep up with my explorers. I love this. So West 7, North 2. This is North 3. Oh, look at that. So it knows it has to go back through the homeroom. So that's cool. Okay, what if I refresh... refresh this, open this up, roll home, exploration, and there are more rooms here now. And look at that, these new rooms that have been discovered, we know facts about them, right? So we know where are the sources, where's the controller, what's the ownership. It's working. I love this. And we should be able to see this from the world view as well. Like we'll see our little green dot running around. Not sure where it went. I don't think I can see it. Oh, it's traveling right here. See that? You can use game map visual to directly visualize on the world map. Oh, so then you could probably say like, my explorer is in this room, right? Yeah, I should do that. Great call. Only in the new alpha map. Do you know if the new alpha map like loads faster? Like the client is different? Because I mean the desktop client is really laggy. Like it's struggling right now with all the CPU usage. Look at this. It just went into here. And I think that's all the rooms that are distance 2, but maybe I'm wrong. Oh no, now it's got to do this room. So I think we could get more clever later about like explore, like whatever room you're closest to, go explore that first. But I don't know. I'm not super worried about that at this stage. Alpha map is GPU rendered. I'll bet that is way faster. Sweet. Yeah, I will check out the alpha map then. Cool. And alpha map displays room decorations. I like that. Which are pretty cool actually. Cool. Well, friends, like it worked. I love this. I'm so excited. This is really cool. Yeah, the explorer's just hanging out here now. Oh, look at that. It's in a loop right now, apparently. So that's kind of funny. We need to... Okay, cool. That'll be for another time to fix, I think, but... Yeah, we'll switch back over to here. Cool. And I think this has been a very successful session. So, yeah, thanks everybody for tuning in. I saw the numbers kind of ebb and flow a little bit. So for anybody that's new... this is Code Gets Creative. This is like all sorts of creative coding happens here. So Screeps falls under that category, like game development as well falls in that category. I also do a lot of like making, maker type stuff. So if you're into electronics, for example, I actually am running my stream today from this little DIY board right here. I can like switch between my OBS streams. So yeah, if you want to learn more about that kind of stuff, tune in. We're going to do generative art, generative music with like synthesizers back here. Yeah, should be very fun. Yeah, please follow or subscribe. Would super appreciate that. Would love to see you again. Yeah, and again, this is Code Gets Creative. I'm Andrew. Have a good one. Stay creative.